Hello and welcome. In this video, we're going to talk about midpoint and distance. We're going to learn the formulas for how to compute the midpoint, the coordinates of the midpoint, and how to find the distance between 2 points. So let's go ahead and jump right in. So we have talked about midpoint in terms of a segment and the point in the middle, but we haven't talked about that with respect to the coordinate plane. So we know that the midpoint represents the point in the middle, but we haven't talked about how to compute that in a coordinate plane. Well, the middle is really just about finding the average. So finding the average of the x coordinates and finding the average of the y coordinates. And to find the average, we're going to add the two endpoints, the two x endpoints, the two y endpoints together, and then we're going to divide them by 2 because we're looking for the middle of these 2 points. So if we were given 2 coordinates, we're finding the average of the x values. That will be the x value of our midpoint. So in this case, the average of 1 and 2, 1 plus 2 divided by 2. 1 plus 2 is 3. 3 divided by 2 is 1.5, which we're just going to leave as 3 halves. Similarly, I'm going to find the average of the y's. 6 plus 4 is going to give me 10, and I'm going to divide 10 by 2 to get 5. So the midpoint between the point 1, 4 and the point 2, 6 is the point 1.5, 5. So that's the idea of midpoint. Let's talk about distance and then jump into some examples. If we are talking about the length of a segment, as we did when we learned the ruler postulate, we're talking about how long a piece of a segment is. When that's just a number and not in a coordinate plane, we can use a tool to measure. In a coordinate plane, we need to look again at our x coordinates and our y coordinates to determine the distance. Now, this formula looks really kind of confusing and like a lot to memorize, but really what this formula is it's just saying what happens if we take this segment and we turn it into a right triangle so that we can look at the change in the x value and we can look at the change in the y value in order to determine the third length. And if you notice, when we do that, we have a right triangle, which means we can use the Pythagorean theorem. This length, which we would normally call c, the hypotenuse in the Pythagorean theorem, is represented by the points a, b, or the length from a to b. ab squared would equal ac squared plus bc squared. So really, this isn't a whole other formula to memorize. It's just a specific manipulation of the Pythagorean theorem. So let's look at a quick example here. If we were given 2 coordinates, visually, we could quickly sketch a graph. And once we have the graph, we can see what's happening with our change in x and our change in y. So our change in x here, we're going from 6 to 7, that's 1. Our change in y here, we're going from 2 to 4, that's a change of 2. So if I was going to find the hypotenuse, let's go ahead and call that c. Using the Pythagorean theorem, we would say c squared is equal to a squared, in this case 1 squared plus 2 squared, which means that c squared would equal 1 plus 4, 5, which means that c would be the square root of 5 if we're talking about the length here. This really is exactly what we're doing when we're using the distance formula. We're just writing it out where we're comparing the difference of x and the difference of y in a more formula-styled way. So let's go ahead and look at some examples of distance and midpoint. Okay, we are going to find the midpoint, and for the first couple examples, we are actually going to create a graph to make sure that it visually makes sense, not only what we're talking about, but the answer that we get, that actually does look like it is in the middle. So go ahead and pause the video, and for both numbers 1 and 2, plot the 2 points that are given and label the first one R and the second one S. Okay, so if we're looking for the middle point, what we're going to do, and we're going to call that midpoint M, what we're going to do is we're going to average our 2 x values. So our x values are 1 and 4. So we're going to say 1 plus 4 divided by 2. And then we're going to average our 2 y values, negative 3 plus 2 divided by 2. And then we're just going to simplify. 1 and 4 makes 5. Negative 3 plus 2 makes negative 1. So our midpoint is the coordinate 5 halves, or 2.5, comma, negative 1 half. And then I want to look at this graph to make sure that makes sense. halfway between, yeah, about here looks like maybe it's 2.5, negative 1.5. So visualizing by quickly sketching a graph might help you wrap your head around whether or not your answer makes sense. I'm going to encourage you to try number 2 on your own. Identify your 2 x values so that you can average them. Identify your 2 y values so that you can average them. And then simplify your midpoint. And then unpause the video and see how you did. All right, so if I'm looking at my 2 x values, I'm getting 2 and 1. If I'm looking at my 2 y values, I'm getting 1 and 4. So my midpoint is going to be 3/2 and 5/2. So 3/2 is the x coordinate of my midpoint and 5/2 is the y coordinate of my midpoint. Now let's look at some examples where we don't have to sketch a graph. So on these problems, we're not given a grid. That doesn't mean you couldn't create a graph if you wanted to, but really what we're doing is we're saying that the midpoint of A and B is the average between the 2 coordinates that we are being given. So our x coordinates are 1 and 7, and our y coordinates are 2 and 8. And then we're just going to go ahead and simplify that. 1 plus 7 is 8, half of 8 is 4, 2 plus 8 is 10, half of 10 is 5, and these are the coordinates of our midpoint. Go ahead and pause the video and see if you can work through number 4 on your own, and then unpause the video and see how you did. All right, so again, here is the setup. I'm going to identify my 2 x coordinates, 2 and 4, my 2 y coordinates, 6 and 8, and then I'm going to go ahead and simplify. 2 plus 4 is 6, half of 6 is 3, 6 plus 8 is 14, half of 14 is 7, and there I have the coordinates of my midpoint. All right, now let's talk about distance. I'm going to, again, have you pause the video and plot those points, and then actually see if you can draw the triangle, the right triangle that would create those 2 points, and then unpause the video and we'll work through the distance portion together. All right, here we go. Let's start by drawing our triangle. So our x's are changing with a total distance of 2, and our y's are changing. Again, I'm just turning this into a right triangle so that I can count 1, 2, 3, 4 of 4. And then you can really just think about this as the Pythagorean theorem. But if we're going to set it up, if we have R and S, if we're going to set it up using the distance formula, we're going to say the square root of the difference of our x's squared minus plus the difference of our y's squared. So the difference of our x's squared, our x's are 4 and 2. And our y's are 3 and negative 1, so 3 minus negative 1. And then if we simplify this, we're going to get the square root of 2 squared plus 3 minus negative 1 is going to become positive 4 squared. So then RS is going to be the square root of 4 squared is 16, 2 squared is 4, so we're going to get the square root of 20. Now, I want to remind you that in Algebra 1, we learn how to simplify square roots. We learned that by the upside down birthday cake. So I'm going to divide 20 by 2 to get 10. I'm going to divide 10 by 2 to get 5. So that means the square root of 20 is equal to 2 times the square root of 5. Another way that I like to do that is to say 20 is the same thing as 4 times 5. And I know that the square root of 4 is 2. So it doesn't really matter how you simplify your radical, but we are going to be simplifying our radicals. So this is the setup using the distance formula. But I want you to notice that if we just draw the right triangle, we're doing the exact same math. 2 squared plus 4 squared equals RS squared. This is going to give me 16 and 4 is 20 equals RS squared, and then we're square rooting, and it's going to get us back to the same place. So it's not that you're memorizing a brand new formula, it's that you're using the Pythagorean theorem in a different way. Now, if you don't have a graph, it's a little harder to use the Pythagorean theorem, and it makes more sense to just jump into the distance formula, but you could always create a graph. So if we look at number 6, and again, I'm going to go ahead and mark up my y change and my x change. It looks like my x change is going to be 2 and my y change is going to be 2. But let's confirm if our formula matches that. Now we have C and D. So the length of CD is going to equal the square root of the difference of my x's squared plus the difference of my y's squared. So my x's are negative 4 minus negative 2, and my y's are 3 minus 5. So that's going to give me CD is the square root of negative 4 minus negative 2 is going to become negative 4 plus 2, which is going to become negative 2 squared. 3 minus 5 is negative 2. So we're going to end up with the square root of 4 plus 4, or the square root of 8. Again, 8 is the same thing as 4 times 2, and I'm breaking it into 4 times 2 because I know that the square root of 4 is 2, and I can simplify this radical to be 2 times the square root of 2. Let's look at a couple examples where we aren't going to graph first. Now remember, even though these two examples don't give us a graph, you could absolutely sketch a graph off to the side and work through this thinking about it as a right triangle. But if we're just going to use the formula, we can say the length of RS is going to be equal to the square root of the difference of our x's squared, so 2 minus 1, plus the difference of our y's squared, 1 minus 4. Make sure that you are consistent with which one you're calling your first point and which one you're calling your second point. Otherwise, you're going to throw off your answers. Now we're going to simplify inside the radical. 2 minus 1 is 1, squared is 1. 1 minus 4 is negative 3. Negative 3 squared is 9. So RS is going to be the square root of 10. And 10 doesn't simplify, so we're going to just leave this as RS is equal to the square root of 10. Okay, I'm going to encourage you to pause the video and work through number 8 on your own, and then unpause the video and see how you did. All right, hopefully you had time to work through this. I'm going to start with my setup. My x1 and my x2, I'm going to have 1 minus 4. My y1 and my y2, I'm going to have negative 3 minus 2. So RS is going to equal the square root of negative 3 squared, which is 9, plus the square root of negative 5 squared, which is 25. This is going to give me the square root of 34. 34 is 2 times 17, and 17 is prime, so that's not going to simplify at all. All right, the last thing we're going to do in this video is one more midpoint example that looks at the midpoint formula in a different way. Not so straightforward, here's 2 points, find the midpoint, but in sort of a different format, and then we'll go ahead and wrap up this video. All right, here we go. The midpoint and one endpoint are given. So this is a key difference. We are not given 2 endpoints and being asked to find the midpoint. We're given the midpoint and we're given an endpoint. Find the coordinates of the other endpoint. So we know that the midpoint is equal to the average of the x's, so x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So let's plug in what we know now. We know that the midpoint is actually 4, 8. We know one of our x values is 2, so 2 plus x2 over 2. And we know one of our y values is 6, 6 plus y2 divided by 2. Now, if we look at this, what we can say is, well, we know that this is going to be equal to 4. So let's set that equal to 4. So 4 is going to equal 2 plus x2 divided by 2. To undo divided by 2, we can multiply both sides by 2. Then we can subtract 2 on both sides, and we're going to get that the x value of the coordinate that we're looking for is 6. So I'm going to just underline this because I know I'm going to need this later. And then I'm going to do the same thing with our y values. And I'm actually going to encourage you to pause the video, set up 8 equals 6 plus y2 over 2, and see if you can solve it on your own, and then unpause the video and see how you did. Hopefully you had time to work through this. We're going to multiply both sides by 2. That's going to give us 16 equals 6 plus y2, which means that y2 is going to be 10 if I subtract 6 on both sides. So I want to make sure my final answer is answering the question that was being asked. If we know M, the midpoint, and we know G, what we're finding is point H. We're finding the coordinates of point H. We found that the x value was 6 and the y value was 10. We could check that our answer is correct if we took H and G and found the midpoint. So 2 plus 6 is 8. Half of 8 is 4. That X value is right. 6 plus 10 is 16. Half of 16 is 8. That value is correct. So I like this example because it pushes us a little further and makes us think about this problem in a slightly different way. Let's go ahead and wrap up this video. All right, so 5.1 focused on midpoint and distance, using the formulas for midpoint and distance to find the length of a segment or the middle point of a segment. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.